Hello.
Good morning.
Morning.
I got My mom got me a gamer headphone. The gamer headphones. Aren't they
Oh,
pretty cool?
nice.
They're PlayStation 4,
Cool.
but it works on a computer somehow.
Huh.
And the cool thing is,
I can't hear you. Yeah, I can't hear you when you have that.
if I flip it up, I'm muted.
Huh. That's interesting.
So if you got some embarrassing so now if I got some embarrassing family screaming at each other, I could just flip it up and you won't have to hear them. Don't you all have that sometimes
Oh, yeah.
where your family is just like yelling and you can hear them across the house or something like that?
About a week ago, while I was doing my AP conference, my mom calls on the phone.
Oh,
Yeah, she's like, "Where are you? Why aren't you picking up the phone?" I'm like, "Oh my gosh, how embarrassing."
wow.
Yeah. All right, I think we're. Oops, I just had some more.
So
Okay, I think we're gonna go
honestly,
ahead
I
and.
thought you would start. I thought you would come on a little bit earlier, as
Well,
like you usually do.
yeah, I usually do, but I was trying to get something else ready. I didn't have time to get it ready though. I'll just have to explain what it is and then tell you about it in a little bit. All right, so I think I'm going to go ahead and get started. Let me share my screen. Okay, so the thing that I forgot to put on here is that I'm going to put a link right. So here's Monday. Hopefully you can see that. Over here where it says assignments, I'm going to put a link over here to the missing assignments, or not the missing assignments, but if anybody has any missing assignments that you could make up from previous days. And just to get you a head start on that, if you have anything missing from April 6th all the way up to now, you can go ahead and make that up. I would like you to schedule a meeting for Friday to meet with me so I can help you make that up. And the way you schedule is you click on this office hours and schedule time. So I'll put more details up here. I just forgot to do that. All right, so today what we're doing is we're finishing whiteboarding worksheet 3, and then we're going to start whiteboarding worksheet 4. So worksheet 3, again, when you click on this folder, there will be a period 1, period 6. You'll click on your folder, and the problem that we're doing here, let me go back. It's slow, my computer's slow. So let's say I pick on Riley's here, if I can open it. We've already done, I believe we've done 1 through 6. I don't think we've done 7. Have we done 7? Yes, we did do number 7. So maybe it's 8. Is it 8? No, we did 8. So it must be 9. Ah, that's it. Okay, so number 9, number 10. So we have to finish these up. And
Yeah,
so
mine too.
again, what we're doing is you're sketching a picture, or you can go on the internet and find a picture. And then you'll read through the problem to figure out if it's balanced or not. And the hint is it says accelerates. Then you're gonna draw a force diagram, then you're gonna solve it. So when I'm reading through this problem, I kind of skip all the numbers, and it says a skydiver falls toward the earth. There's a force of air resistance acting on him or her, and it wants to know what the acceleration is. Okay, so I am going to, just like last week, put you in breakout room groups. That way, when you're in your group, you can kind of talk to the people in your group. And you could even, if you wanted to, you could even go on their whiteboard. Oh, shoot, it didn't. Shoot, that's the other thing I was doing. It didn't work. Dang it. Shoot, it was supposed to put you in groups. Sorry, I don't. It's going to take a second. All right.
Right. Yeah.
I apologize. So I must have did something wrong, evidently. Sorry, it's taking me a while. Okay, sorry. That was something I thought I set up. It didn't. Okay, so I'm going to give you the invitation now, so it should be coming. Dang it. You all doing okay? Okay. You could talk to one another. Are you guys talking to one another?
Yeah, in the
Okay.
chat.
Oh,
Jazz Microphone is glitchy, so.
Oh, okay, gotcha. Okay. I'm going to check out the other rooms.
All right.
Yeah, I have no idea what to put down for the FNet.
Are you guys doing okay?
Yeah, we don't know. So do we add them together, right?
Well,
We add the,
they're in opposite directions, aren't they? There's a force downward.
so subtract them.
Right, you subtract them. And that will be your net
Oh.
force. Yep, that will be your net force then. Devonta, you doing okay?
Yeah.
Okay. I'm going to check out some of the other rooms. How much more time? Maybe a minute or two?
Something like that.
Okay.
Goes.
Doing okay?
Yeah.
You able to chat with one another, hopefully? Okay.
Yeah.
Right. Okay. I'm going to check out some of the other rooms. You guys doing okay?
We need a little bit of help.
Okay. Wow, that's a pretty cool picture. So what forces you think would act on it?
Gravity.
Force of
Yep,
gravity.
there's
for
gravity.
sure.
So you draw an arrow straight downwards. Yeah, you change it to a straight arrow. See up, there you go. Up.
Yeah.
And then
And-
so we're drawing the force diagram.
Yep. So have an arrow going straight down. That would be a force of gravity.
Yeah, because I go right there.
And do you see how it says in the problem, there's a force of air resistance? Which way do you think air resistance would be?
Upwards.
Yeah, and which one's going to be longer if they're accelerating downward?
That one.
Yeah, the downward, right? So when you draw an upward arrow, don't make it as long as the first one you drew. So just kind of a short arrow. There you go. That works. Okay, that's it, I think. And then do you see up there where you found the arrow? Just to the right of that is like the letter T in a square. Click on that.
Yeah, right there.
T in a square.
Yeah, kind of up near the left.
Right here. The T with the block around it. You can click on it, Josh. No, you can't. This is
Up in the ribbon there.
This is the thing. This is the thing.
Okay, is this Josh that has this one?
No, this is me.
Oh, okay, Kari. So, Kari, do you see right above the word physics for physics first? There's like a little mouse. There you go. Click on that. That way you can put in FG and FN.
Mm-hmm.
Or not FN, F drag, I guess. F drag. So F drag for that one. And then the one down there would be FG.
Let's draw another one down here. Let's draw another one down there.
He could just simply hit return or space it over. That would work. Or yeah, you can just do another one. That would work. Yeah.
So down here.
Yeah, and then put FG there.
And then delete this one.
There you go. And then get rid of the FG up there here. Keep the drag though. Okay, then how would you figure out what FG is? Anybody have?
You know how to? No, I don't know how to.
Okay, do you see the equation right above, right above the problem? It's kind of below physics first. It says FG is equal to M times 10.
Yeah.
So we need to know the M. What's the M for this person?
Say 70.
Yeah, it's 70. So FG is going to be 70 times 10. So we have to take a calculator and figure out what 70 times 10 is.
$700.
Yep, so FG is 700.
There we go.
There you go. And then the drag, it tells you in the problem, it says the force of air resistance is 500. So F drag would be 500. Okay, so now we have to figure out what the total force is. So do you see how there's two forces? The drag is upward, that's 500, and we got an FG downward, which is 700. Do you think you're gonna add them or subtract them?
Add.
Well, they're going in opposite directions though.
Subtract.
Subtract them, yeah. So why don't you do 700 minus 500?
And do I put it in this one?
You actually have to make another one. We're going to write an equations. So Kari, make another one and write F net equals MA. F net equals MA. And so Josh, did you happen to calculate what 700 minus 500 is?
Right one.
200.
Oh, it's 200, yeah. So now,
Yeah.
so Corey, if you can hit enter a couple times and put 200 equals, and then what's the M again?
70.
So equals 70 times A. And then how would you solve this? Jacob, Josh, Kari?
Would we just need to find out how many times 70 goes into 200?
Yeah, so basically you're just going to take 200 divided by 70, and that will be your answer.
Look at your calculator.
Okay, so I'm going to exit this meeting and then call you guys back, and then we'll go over it, okay?
Oh,
You're
the
doing,
answer is like 2.85 something.
yeah, why don't you just round it to 2.9? That's
Mhm.
it. A is 2.9.
Okay.
Hello.
Hi.
You know, it's crazy that I woke up at 6 o'clock, but I still haven't had breakfast yet.
Oh, you're gonna be hungry. Okay, so everybody should be coming back here in a second.
Oh,
All right, so the first thing I want to do is I kind of want to get a picture of everybody for attendance. So let me get a snipping. So I'll tell you like in count of 3 or something. So if you can kind of turn on your camera, Jacob, Devontae, just for a second, even if it's kind of pointing up toward your ceiling or something, or so I can see your fingers or something, give me a thumbs up or something. So count of 3, I'm going to take a picture. 1, 2, 3.
I posed.
Thank you. I'll save this. Nice pose.
Let's do it.
All right, let's see. Oops, sorry. It's taking me a little bit here. Oh, there it is. Sorry. Okay, sorry it took me a little bit there. Now, does anybody want to share their screen and kind of go over their answer, or I can do?
I could.
Kari, you want to do it? Or I thought somebody said it.
Yeah, I said it.
Yeah, there you go.
Okay.
Cool. Nice. And so everybody check out that picture. That's pretty awesome. Did you find that on the web?
Yeah, I just looked up like a stick figure and just turned it upside down. So
Cool.
Where'd you
Nice.
get 2.9 for the acceleration?
Well, yeah, let's see how he did that. So it looks like his force diagram, he's got 2 forces. He's got a force of gravity downward. Does everybody agree force of gravity downward? Yeah, that's right. And there's a drag force upward from air resistance. And it says the drag force upward is 500. I think we all agree on that. And the force of gravity, you have to do Fg equals m times 10. So is everybody okay with those two? Okay, so to find the net force, you have to do 700 minus 500, and you get 200. So then if you could on your calculator, so we're going to check this because Noah asked about it. So could you take 200 divided by 70? Yeah, I get 2.857, so I think we're just rounded to a tenths place. That looks pretty good, 2.9. So Noah, are you
Okay.
okay? Does that make
We-
sense?
We just ran into the hundreds place.
Oh, okay, well, both the answers would be fine. So 2.86, 2.9, they're both okay. Any questions? Nice, Corey. Everybody give Corey a hand. Thank you. Yay, it's down at the
So I
bottom.
just push
Yay.
stop share.
Yeah, stop share. Nice, yay. Okay. So let me show you the next problem. Share my screen. Okay. The next problem, number 10, it's the last one from this worksheet. Okay, so it's a skydiver again, so you might be able to copy and paste a lot of the stuff, except now the chute opens up. Instead of the drag force being 500, now it's 1200. So first of all, it doesn't tell you in the problem, but it's the same problem as before. So the mass for this is just the same as before. It's 70 kilograms. Okay. So I'm going to let you get back in your groups and kind of work out this problem then. Here comes the invitation.
My computer died. I'm sorry.
Oh, no problem. So you should get another invitation to go back in. No big deal.
Okay.
Doing okay?
Yeah, we're almost done actually.
Nice. I think I'll stick around and see what answer you guys get then.
We're just about to put it in. Is that okay?
So what'd you get?
We got, or I got 7.14.
Yep. Yep. Nice. Good
That
job.
good?
Yep.
Okay.
I'm gonna go check out the other. Doing okay?
Yeah.
Did you guys get an answer? Or are you getting close?
Yeah.
I'm working
We're-
on it.
How many forces are there on this one?
2.
2, right? Which one's bigger, the one down or the one up?
Up.
Yep. So Monty, did you get an answer then? Sounds like you're really close, like for the acceleration. I think I lost her. I think she cut out. Oh, there-
I'm about to divide it right now.
Oh, okay.
God.
All right, I lost you. You cut out on me. Can you repeat it? I couldn't hear you. Kind of cut out.
I can hear you fine
Oh.
now. Can you hear me?
Yeah, I can
Okay.
hear you. So what'd you get for
Okay.
what'd you get for the acceleration?
It's 0.17.
Oh, I said, I think you divided it the wrong way. I think you want to do, so you took the number divided by the other number. I think you want to reverse it. So I think you want to take the first number divided by this other number.
Okay. Okay, I got 1.7.
Oh, wait a second. Okay. So yeah, something didn't work out. So what were your two forces? How big were they? How many newtons for each of them?
So my up force, I just did the 1,200.
You're cutting out on me again. Willow, Kyle.
And then
Oh.
the down force.
Okay, so then what'd you do with those two forces? Did you add them or subtract them since they're in opposite directions? Willow, Kylie, did you guys get an answer?
I'm still kind of working on it, but
Okay.
I subtracted the top
Yeah.
from the bottom.
Yeah, what'd you get when you subtracted? What'd you get? How many newtons? I think my connection must be bad. I'm not hearing you guys. Okay, so I'm going to go check out some of the other rooms and probably come back. So you guys doing okay?
Yep, we got it. I
Okay.
think.
Yeah, that's it. That's it.
Right.
Nice. Good job. Excellent. I'm going to check out some of the other rooms. Looks like you guys are done then. Oops.
Yep.
Okay.
Let's see.
On the box if we're not one.
Okay, so would somebody different like to share their problem for this one? So Kari did the last one. Somebody else think they might want to share? Okay, Noah, you want to go ahead at the very bottom? There's a share button. If you want to click on that share screen and okay, nice. And so I hope everybody can see you got two forces, a drag force and a force of gravity. A drag's bigger. And then, oh, what did you do after you had your force diagram? What did you have to do?
We had to get the F net, for total force. Divide that force by the mass of the glider, and then we found out the acceleration was 7.14.
Nice. So I have a question, Noah. Why did you're absolutely right, by the way, you did it right. Why is it that you subtracted the two forces?
They're both in the opposite directions.
Opposite direction. So what's really weird about this problem, so I'm so glad you got the pictures there, Noah, so we could look at it. What's really weird about this problem is they're moving downward, but the acceleration is upward. So I want you to think back when we did kinematics. What happens to an object when the acceleration is one way and the velocity is the other way? Does it speed up or slow down?
Slow down.
Yeah, that's exactly what's going on here. So the person is slowing down to get a nice safe.
So it's not going up.
No, they're not going up. They're still going downward. It's just that the
Going real slow.
acceleration is up and that makes them slow down. Okay, so everybody at the very bottom of your screen, there's a reactions. So give Noah a hand. Yay. Yay.
Thank you.
Yay. Okay, if you could stop sharing.
Stop share.
Perfect. So we're going to do one more. Let me share my screen. But this one's going to be on, this is going to be on worksheet 4. So it's a new worksheet. So let me take you to worksheet 4. So again, there's period 1, period 6 here. So you'll click on period 1. And I clicked on it. It's just a little slow. And we're only going to do one of these today. These are actually a little bit easier, in my opinion, than what you were just doing, because they're not really word problems. I'm kind of giving you the force diagram. But you have to fill in the blanks, okay?
I don't know which one is worksheet 1 or worksheet 2. They're all
Okay.
just...
Okay, so again, if you go back to the Canvas page, the physics first agenda, and scroll down to number 2 here where it says we started whiteboard worksheet 4, and if you click on this link here, it'll take you to a folder that will be the right folder. It'll be correct. It'll be worksheet 4, and you'll just, okay?
So I'm at the folder, right?
Yeah.
Names. It's the only when I hover my mouse over it, then it tells me which problem it is. It's not showing me the problem right away. I have to hover my mouse over to see which one is which.
So, like right here, I'm in Riley's. Yours doesn't say like a copy of Dynamics worksheet 4, number 1.
It just says copy of Dynamics worksheet, and then it gets cut off because it's out of the space.
Huh.
Because your screen sorts it differently than my screen does.
That's interesting.
Your thing, yeah.
Well,
So I think it's...
you might just have to click on each one of them, or maybe, yeah, like you said, highlight or hover over it, and then click on the one that says worksheet problem number 1. And
Yeah.
what you have to do, because the force diagram is already drawn, is you have to fill in the blanks.
Really?
So, for instance, if you don't know what the net force is, then you're going to use F net equals ma. If you don't know what Fg is, you're going to use Fg equals m times 10. And so that's what you're doing. You have 4 blanks to fill out. We also have to figure out if it's balanced or unbalanced. So let me stop sharing, and I'm going to have you go back in your breakout rooms, and this will be the last one, okay? Sorry I'm calling you back so quickly, but I didn't realize time kind of got away from me, and I don't want to go this long, so sorry about that. I'm going to quickly show you how to solve this problem, and then we'll call it a day.
Okay.
Okay, I'm going to get a picture one last time. The reason I'm calling you back is because I didn't realize what time it was, and I don't want to keep you that late. So let me get what picture one last time and show you how to solve the problem, and then we'll kind of call it a day. So let me get a picture. Count of three. 1, 2, 3. Okay, let me save that. Okay. Let me save my, or there we go, share, Okay, so the way I solved this problem was I knew the equation FG equals mg up here. So I wrote FG equals m times 10, because G is 10. It tells me the mass is 45 right here in the middle of the picture, 45. So I did 45 times 10, and I found that FG was 450. So I put that in the blank. The normal force has to be the same size as the force of gravity, assuming this is just, it says something's on the floor moving to the right, so they must be the same size. So if you look at this, I have 15 friction to the left, and I have 15 friction to the right. I have 450 newtons down. I have 450 newtons up. That means the net force would be 0 because they all cancel. And if the net force is 0, it's not accelerating. The acceleration is 0. Now, the last thing I want to do together is this. Kind of want you guys to unmute yourself. Is this balanced or unbalanced?
Balance.
It's balanced. It's balanced, right? Because the forces cancel out. So I'm going to circle balance.
Trigonometric.
Balance. Okay. So that's it. All right. So let me come back to the calendar here. So for the people who aren't in attendance today for this meeting, they are going to be doing the attendance quiz. So let me show that to you real quick. And by the way, you could do this for bonus if you want, because it's similar to stuff we just did. Here's the code. The code is, hold on a second.
Adding and subtracting complex numbers. Again.
Okay, the code is 3SD4SQ, and those were all lowercase, and then uppercase FSW. So 3SD4SQ, those were all lowercase, and then the last three are uppercase, FSW. There's only 4 questions there. Again, you guys don't have to do them, but if you do them, it would be as bonus, so that might be nice. And the other thing that I would like you to do is I would like you to kind of keep on working on those worksheet 4 problems that we kind of got started on, so we can maybe whiteboard them a little bit faster. I think they're kind of easier too, but you don't have to have them done. Just kind of keep on working on them. So let me stop sharing. Any questions? Okay, that's it. Sorry it went a little long. Bye. Bye.
Bye.